Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, it's my pleasure to welcome Joanne Shatkin, President and Founder of Vireo Advisors. Joanne, thank you so much for joining us today. To get us started, can you just tell us a little bit about yourself and how you got involved in nanotechnology?
Sure, Lisa. Thanks for having me. I'm really thrilled to be here. I decided way back in high school that I could have more impact on society working in the system as an expert than being on the outside, being an activist. So I set out to become an environmental expert, which required interdisciplinary education. In fact, I designed my own doctoral degree, studied chemistry and toxicology and environmental policy at Clark University. And I took courses like in groundwater hydrology so that I could understand the language and also, the concepts from different fields that had to be integrated to find good solutions. I ended up becoming an expert in health and environmental risk assessment.
And how does nanotechnology play a role in that?
I was working with a group on drinking water quality and priorities for emerging substances. And in 2005, my cousin called me and asked me what he needed to do to sell a machine he had invented that makes iron nanoparticles. I found it just so interesting when I started to dive into the literature that I was getting up early on Sunday mornings to read technical papers, and that's not typically how I work. But I was really excited about the opportunity to find ways to help establish the safety of these materials. So I started writing and speaking, and I met both my first client and my publisher at the same conference, the first one I went to back in 2005.
You mentioned water. I think that water is an area of interest looking forward, opportunities to clean water for remediation, but also for detecting things like the incidental microplastics that we're finding now in waters. How did you go about doing a risk assessment and maybe particularly looking at water systems?
There's two key components to risk analysis. One is kind of hazard or toxicity, right? So what is it that you're concerned about and why? And chemicals, you're concerned about their adverse impacts, or viruses or other microbes, you're concerned that they will make people sick immediately. And then with other substances, you're concerned about, do they break down and have breakdown products that could be hazardous or even just persistent in the water and travel far. And the other component of risk analysis is exposure. And so we built these huge data sets of different chemicals and biological hazards, and then looked at exposure potential and kind of figured out what rose to the top in terms of priority. It was a big data mining exercise, but also modeling.
So when you do data mining and developing data sets and the methods to get at this information, can you discuss a little bit more about other systems or materials you've looked at and how you gathered the information necessary in order to do the type of assessment that you conduct?
Sure. As you know, Lisa, I've been working with cellulose nanomaterials for more than a decade now. The first project we did back in 2013 with the Forest Service was look at all these different applications that were coming down the pipeline and think about the potential exposures, how those applications were going to be used and who would be using them. And from that, we built all these different exposure scenarios that might occur either in the workplace or when consumers were using products or if those products entered the environment. We then looked at what we knew about toxicity or hazard, and then looked at what we didn't know and really needed to know in order to be able to assess the risk. And from that, we developed a roadmap where we prioritized what information we needed. And since 2014, I've been working with dozens of collaborators to try to answer those questions in that priority.
Let me pick up on a thread that you just laid down, and that was that you have a number of collaborators that are working with you now. And can you describe the collaborations, the type of researchers, the type of backgrounds, and perhaps where they live in the technology development pathway?
Sure. So since 2016, my group at Vireo Advisors has been coordinating a consortium of organizations, and there are 10 funding partners that include USDA through the Forest Products Laboratory and the U.S. Endowment for Forestry and Communities, and 7 companies, both in the US and internationally, small companies, large companies that are producing these materials or using them in applications. And even Innovation Engine, Alberta Innovates, is one of our partners. So they all have this shared interest in building up the data sets, helped us modify the methods that are already available and have been used to demonstrate safety of all kinds of substances over time and are harmonized across different geographies. But we came across, for example, we've been focused on safety in food and food contact applications. So whether it's edible packaging or just better barrier, bio-based materials, all kinds of interesting applications. But because it's cellulose, it's a carbohydrate, it's a sugar. So detecting that, even in air, became a research project. And so we worked with Tom Peters, an industrial hygienist. And then when we got into the biological media, we couldn't really sort out how to measure the cellulose as we added it to food to do a dietary study. And so we worked with a commercial laboratory that made these diets for, to feed to the rats. And we also worked with scientists like Christy Saves at Baylor University, who is both a chemist and a toxicologist, and Douglas Fox at American, who's a chemist. And he helped us label the materials so we could spike and then be able to determine how much was there. And it required this combination of both people who've been working for a long time on safety, but also researchers who could help problem solve these challenging detection issues that, when we got started, I had no idea it was going to be this hard to do. So our most recent issue is that we have these 7 industrial materials, plus we did the studies with conventional cellulose and material that the University of Maine, through grants program, has a pilot facility, and they've been supplying people with fibrillated cellulose and cellulose nanocrystals through the pilot facility. So we tested that material, and then we had to relate that to the industrial. So we have the side-by-side physical, chemical, biological testing that we've applied to the 9 different materials. Well, we've come across a real challenge in describing what fibrillated cellulose is. We're really good at measuring the nano properties of it. As you know, I don't want to get into the terminology and definitions, but it's very difficult to sort out how to describe a kind of amorphous material that's agglomerated. It's not a spherical, tiny particle. It's a massive fiber. It's kind of messy. And so we just brought together an international group of experts along with the industrial partners to sort out, how do we do that? How do we do that kind of characterization in a way that is reliable, repeatable, not a research study, and try to build on some existing standards, but at the same time had to navigate our own path.
I want to hit on the interdisciplinarity that you just described, and not only the different technical expertise that were brought to bear. You mentioned chemistry and toxicology and biological studies and physical measurements, but also across the entire value chain. It sounds like you have folks who are early stage researchers. You have people who are working on the application or the use of these materials. You have producers of the material, implementers. It seems like a big team with very different perspectives. How does that add value to your work? And also, you mentioned very early in your introduction about taking courses so you understood the language. So how does the language work across these very different backgrounds?
Oh boy. Well, now I'm going to go off on the language part because, first of all, it's different disciplines. Second of all, we're on Zoom all the time. We're not in the same room. And we also have a lot of non-native English speakers. So language is really important. And how you describe what you're doing, it requires a significant effort. But as you said, it is exciting. I think the challenge of bringing everybody together for a common purpose is, I couldn't believe how many people were interested in this problem, but they really are. They really show up. And as I mentioned, we built this expert group. Well, not everyone was a characterization expert, but they all knew either they knew their material very well or they knew certain type of measurement methods very well. How it works is kind of remarkable in the ways that people learn from each other and gain new perspectives on issues that they hadn't really thought about.
I understand that you work with students of a variety of different levels. Could you talk about your work inspiring the next generation?
Sure. As you know, we're a private company, but we are mission driven. We all get out of bed every day to try to bring better technologies to our societies. We are focused on how do we enable those innovations. And we've created an intern program. Interns are great to help us on shorter term challenges, maybe over the summer. We've had some that have worked with us for 2 years, but from PhD candidates who spent a day a week working on what they thought was kind of fun challenges of writing about technology, helping us explain some of the concepts that we're working on around nanotechnology policy or safety, or helping us research different questions that our clients might have. We've just over the past year, we've been growing in our work and have brought on more interns who are at the undergraduate level. So either in molecular biology, chemical engineering, chemistry, we have really solid chemistry questions that apply to how to demonstrate the safety of a new substance or a new nano-enabled technology. And so what they're studying, they can then apply to something in the real world. And I think that is helpful for them to see how their classwork is applied in the real world, how it can be useful to solve problems. And also on the sustainability side, we're looking at how to get sustainability certifications for something brand new. It's not obvious and it's complicated. And so the idea that they can help to work on bringing about that more sustainable economy that they have a vision for, including, and this isn't, it has nano applications actually, but cellular agriculture, cell-based meats that are going to be grown in a lab without being on a farm. That generation is actually really excited about the potential for not having all those environmental externalities associated with the protein that they eat. So they have a lot of fun working with us. We enjoy them and even get their help on our Twitter account. It's great. Some of them have actually gone off to work on ESG, or environment, sustainability, and governance kinds of areas, and others are working in sustainability and life cycle. So I feel like we've had a good influence on the next generation.
That's great. Well, Joanne, I want to thank you again for taking the time to talk with us today. Do you have any closing thoughts that you'd like to share with our listeners?
So innovation is hard, and so many things have to come together for someone to adopt something new as opposed to something they're familiar with. And what we need now is to help overcome some of that resistance to change that's so important. We see that as the way toward a safer and a more sustainable future.